Um, I'm Tom Bragg, and I'm kind of chairing this evening's tour of Bart's home. Uh, and a few Zoom etiquette things first, as usual. Please, can you stay muted until we probably call you to speak if you've got a question. Chris there is going to be watching chat. So if you've got a question, please write it into chat. And then at two Q&A periods, we'll be calling on questions and hearing from you. And we're recording this session so that we can let other people see what's happened afterwards. But if you particularly don't want to be recorded, it won't show your names. But if you don't want to be involved that way, write that in chat and we'll minimize any ways that you might be appearing. I wanted to say that I just love what Bart and Rose have done with their home. I was knocked out when I first visited about 18 months ago. And so they've extended and retrofitted it, but planning it really carefully and then being really thorough in actually how they've done it. And it's lovely. So I'm sure you've got plenty more to learn about it this evening.
Yes, so welcome everybody. Thank you for joining. First, a few words on the Open Ecohomes sort of generic introduction. Ooh, there we go. That's a bit quick. Yeah, thank you first to Open Ecohomes for providing this platform, and let me ramble on about one of my hobby horses. I personally got really enthused by visiting others' homes. I learned a lot. I picked a lot up from other Ecohomes hosts, and I still see some of them regularly. So please support the good work they do by making a donation. That would be really much appreciated. Okay, down to the business of my talk. It's about more space while using less energy, and it's about the extension and upgrade of our 1940s semi. Now, for most people, buying a house is the biggest purchase you'll ever do. I dive straight into the starting point, but I should say this is the outline. I'll talk about our home, how we came to live here, what and how we did for the retrofit, how we went about with the extending and upgrading of our home, and then I won't go into detail on general build, relaying the details of the actual build, but I will focus on the eco aspects of the home, namely the insulation and the airtightness. That includes ventilation. And then I'll show off by showing you some results. So yes, again, this is where I actually started. The home is for most people the biggest purchase of their life, but it's surprisingly irrational sometimes. The house where we came to live, almost 10 years ago, actually, I saw it during an outing with some colleagues, actually. It was in need of some updating, and I wasn't looking at all for a retrofit doer-up or anything. But, as these things go, we took the plunge and quickly actually realized, well, even before buying it, it would be a very long-term project. And actually, that is key for efficient retrofitting. You have to be in it for the long haul. Now, what did we end up with? Very much a British standard 1940s semi. If that tells you something, it's EPC band D. You can see the pictures on the top of the slide. It had cavity walls, one of the first series of properties to do so. They were filled with mineral wool. That was a big plus. It had double glazing, UPVC windows and doors, suspended timber floor in the living room with about a foot of crawl space underneath. Well, a foot is not really crawl space, it's too little. We had a screed on soil floor in the kitchen, which is cold about 11 months of the year, and in the landings. And then, as you can see on the picture, there's the roof line starts just above the windows on the first floor. That means there are these sloping ceilings on the first floor to get the necessary standing height. These were completely uninsulated. There is 100 millimeter mineral wool loft insulation present when we bought it, tucked in between the joists, and it was heated by a back boiler. These things are only, well, between 55 and 65% efficient. So a little less than half of your heat goes up the chimney directly because they vent into an open flue. Furthermore, to get the ventilation required, I'll talk about that later, we had many double brick vents, which are basically holes to the outside, double brick wide with a mesh in front of it to not let any unwelcome visitors in. Then the hot water was taken care of by a standard gravity-fed cylinder with 20 millimeter spray-on foam. Not the worst, not the best, but a lot of scope for improvement. And actually, that's what we started doing. And these things I'm going to sort of talk you through are so-called the low-hanging fruit. There's low investment and an immediate effect. It might not affect comfort much, but you'll see it in your wallet, basically. And these are important. You know, it's also sometimes, especially with open eco homes, it can be a bit overwhelming what people did. But these things are the things to start with. You must do these. They're basically no-brainers. So in our case, that was the hot water cylinder jackets. I bought one, that helped. I bought another one, that helped a bit more, and then I bought a third one. They don't cost very much, I think a tenner or so. Then we went for better central heating controls. We had an old thermostat that sort of would only kick in when you were getting really cold and would stop only when it started to reach tropical temperatures. So we bought an electronic one that was a bit more accurate. And later on, we realized we needed a sort of a scheduled timer because everybody was in work and school most of the day. So then we ended up with a Nest, which is highly recommended. It did the job very well. The real obsession started when I got myself one of these electricity consumption monitors and displays, a bit what smart meters can do now. They display at any time how much your home is using in terms of energy, electricity in this case. And that really, these numbers start to haunt you. If you're sitting on the sofa and you're reading a book, you think like, why has it got to be 500 watts? And you start going around the house, switching things off, and you can only sit with your book again once it comes down to 200 or so. That's what happened quite a bit. To stay with the fruit tree analogy, we planted an orchard in 2011. That was a solar photovoltaics. You can see it on the picture, almost 3 kilowatt peak array, 12 smallish panels. And that sort of gives you so much energy that you start to think about how to use it most efficiently. And then I went for a solar immersion diverter. That was a DIY project where that is a device that monitors how much excess solar energy there is. So it looks at how much is going into the grid, into the street, if you like. And then it starts to fire up your immersion heater to divert that excess energy into your hot water tank. This worked very well, so I upgraded the hot water tank with a heat store. And that now gives me free, so to speak, hot water for 7 months a year, all powered by solar energy. Then a few years later, we had the happy opportunity to build an extension. You can see the modeling work going on in Lego here. That was very useful as well, by the way. But of course, from case studies, I realized that extensions generally increase your energy use. You've got more walls, more volume to heat, more floor, and so on and so on. Windows as well. So actually, I didn't really want that. I wanted to bring energy use down. So I thought, okay, why don't we build this to the standard we would like the whole house to be eventually? Whether we would ever reach that sort of thing, we didn't know. But something I picked up from, I think, the Green Cottage blog, is to have it built to the highest standard, or maybe not at all. Yeah, again, I won't focus on all the details of the build, but I'll talk now a bit more about the main aspects of the work: insulation, air tightness, ventilation, and then a few words on heating and hot water. One of the main things is when you start thinking about, okay, we want to upgrade the home, but how do we go about this? And that is a bit of a tricky question. And actually, if you want to do it right, the best thing to do is to have, well, in our case, the architect was attracted to design the extension, but also to come up with a whole house plan using the passive house planning package software. This software is taking into account the local climate, the shape of your house, how many walls have you got, how much roof surface have you got, the orientation, which glass is south facing, and so on and so on. And then one of the things the architect offered was an options report where it outlines sort of a wish list, saying like, okay, you've got this starting point, and with the extension you end up with an energy use of this and this, and what now do you need to do to attain different standards? And that was really well worth the extra expenditure. I can't recommend this high enough for those people who are serious about a zero carbon, because that's what we're talking about, retrofit, or a retrofit to very high standards. With current building regs, these are not very ambitious in my view, as in reaching zero carbon. They're inadequate for that final goal. If you're looking at very high standards, as the ones propagated by the Passive House Institute, you have to do these simulations, because the more, for example, the more insulation you pack in, the more important it becomes that you don't overheat in summer by having too much south-facing glass or roof lights. Now, this software will point that out before it happens. It is really very good. There's a lot of knowledge, a lot of research that the Passive House Institute did that went into this software. I have to say that with hindsight, I trust the numbers. It's a bit of a gamble, of course, because this report tells you something and isn't really true, and now is sort of a good way in. I can tell you, yes, it does work as simulated and as calculated, and that's a big relief, of course. Okay, more to the practical side now. Insulation, the unsung hero of home improvement. You see on the pictures, you see on the top left, I hope you can see the cursor, that is when the insulation just got delivered. There's a garden full of it. This is the trampoline, actually, so dear daughter had to sort of refrain from bouncing for a good few weeks. You can see the loft where the insulation project is still undergoing, the existing loft. You can see on the bottom left, you see the bottom bit of the extension walls. Cavities are quite twice as wide as building standards, so they're 200 millimeters, fully filled with polystyrene below, and glass and mineral wool further up. You can see the picture of the side of the house. That big wall is external wall insulation, 200 millimeter thickness of polystyrene. That was actually a do-it-yourself project. I had my doubts halfway, but I got it completed. And then that screed on soil floor I was talking about, I think we used this opportunity to go for the whole hog and have that dug up as well. But it means that if you're looking at 300 millimeters of floor insulation, you have to dig almost half a meter down to accommodate it all. And yeah, that left a very big hole. And then even the party wall was insulated, with a thinner layer than all the rest of it. But that is what we did as well. And the U values, if that's your thing, are listed above. So they're all, the floors and the ceilings are have the lowest heat transmission. They lose very little heat, but that is also because, walls eat into your floor space. So they're always subject to compromise. I mean, you would have gone thicker, yes, but then the internal or the external space would have been diminished even further. And twice the normal cavity width, you end up with walls of half a meter thick, basically, which is a lot. I'd like to talk a bit more about the air tightness, and actually it should say air tightness and ventilation, because those always go together. Our home, because of this whole exercise with the Passive House software, out comes, out of the software comes an estimate for your heat losses, and it was estimated that our house, even with conservative leak rate figures, our house was estimated to lose half of its heat during the infiltration of ventilation. And the infiltration there is the unwanted ventilation, basically. The infiltration is air that comes through cracks, service pipe holes, shoddy brickwork, you name it. And ventilation is then the air that comes in through the intended holes, as you sort of. But of course, we do need ventilation. We can't eliminate it completely because that would make our indoor climate very unhealthy. Now, our ventilation is entirely passive. You've got these brick vents, as you can see in the picture. We have chimney stacks that have these vents on the inside, so the stack effect draws air through the house. But it does mean that the wind speed governs how much ventilation you get. Well, this season, especially when it gets a bit colder and a bit more windy, you get lots of ventilation of very nice cold air entering your house, and on those warm summer days, it gets really stuffy because the air is very still and there's not much ventilation happening at all. So it would be much better to have controlled ventilation. And that means that all your unintended ventilation holes need plugging because they can cause cold spots. As you can see in the picture that was taken near our door. The seal behind the hinge was hard to reach, so they probably did not do that very well at the time the door was fitted, and their cold air enters the house, cools down the reveal, and the air, the warm, moist laden air from the inside of the house will condense there and cause mold. You can paint this as much as you like, as I found, but it doesn't really help when the root cause is not attacked. Airtightness, plugging the holes that the builders didn't intend that are in and around your house, all the cracks, all the other things, you can start plugging those today. Well, maybe it would be a bit late, but that's something you could do almost immediately. My advice would be to wait for a windy day, go around the house, feel around with the back of your hand, note down where you think the cold air is coming from, and then on a nice day to work in or outside of the home, start plugging those holes. For the new build, and also when you're sort of having all the fabric stripped down to the essentials when building an extension, it comes down, you can take care of the airtightness properly by using a lot of tapes and membranes. That's where it basically comes down to. You can see in the picture on the left, you can see the main building elements. This is the brown brick wall is the external wall of the existing house, and the block work is then the internal wall of the extension. And of course, you can see the roof and you can see a bit of a window. Now, the wall, all the building elements you can see here are taped together. It's not that the tape keeps them together, but it provides the airtight seal, even if there's a bit of movement. So you can see the white tape building, joining the two walls. The wall is joined to the ceiling with another layer of that tape. And then the ceiling is covered by these sections of that white airtight membrane. Those are held in place by battens, which, and I can tell you there's double-sided tape in between as well. And that yellow tape then tapes the membrane to the wall. I should say that this wall is then later rendered and plastered, and that render and plaster both give you an airtight material as well. And you can see that the airtight layer is completely continuous, where it folds around in the window reveal and meets a membrane there, and then it has tape whereby it is the tape is then attached to the window itself. So there's a completely continuous airtight layer. Most manufacturers are getting aware of this. For example, the roof light picture, you can see a airtightness skirt. This is a kit you can buy as an option with the roof light. And then of course it's cut to size, it fits perfectly, it comes with all the tapes, so you can just install it. It's not too much work to install it. On the top you see where you have to retrofit, and things are not so well designed from the start. It gets a bit more tricky, where you have to make sure your airtightness foils, where they meet the joists, you have to tape around every joist to make a nice cutout that fits the joist, and that's a bit more finicky to deal with. A slightly deformed picture on the right shows you a backing box for an electrical socket. There, you would be surprised actually if you go around your house on a windy day again and you feel in front of these sockets how much air comes through these. Well, of course, the sockets have to be in an external wall. Then you realize why I have to be so tedious about this, because these sockets are now plugged with a sort of a mastic, admittedly not very eco products. There are better ones on the market, but they are there's some black bituminous product I use to seal those holes, because otherwise you have again a hole in your airtight layer. Now, in a perfect world where this would all be airtight, you would have less or no uncontrolled ventilation, but it requires controlled ventilation. And there's a few options you can do, but I chose the one that is the mechanical ventilation with heat recovery, and it's abbreviated as MVHR. What it does is it takes stale, damp, warm air, it sucks it into a central sort of a box, and the box contains a heat exchanger where the heat of this stale, damp, warm air is used to warm up fresh, cool air that is taken in from the outside. Now, what happens is, of course, this fresh, cool air is then heated up and injected in the house, in the bedrooms, for example, as fresh, warm air. Of course, the stale, damp air is taken out where the chance of high humidity and possible pollutants is highest, so bathrooms, kitchens, that kind of those kind of locations. And then what results is that the warmth is taken from the stale, damp air, and what is expelled is stale, damp, but cool air. So you recycle the heat, but you put in fresh air, and that works very well. These boxes are available. They have terrific efficiencies. They can be very silent, and in practice, you end up with something like this. This is again a DIY retrofit, although the design was done by an external company. Our heat exchanger is called Paul, and you see Paul needs a lot of pipe work, tubing, and well, you see here in the top the very well insulated the intake from the outside air. What you end up with in the, for example, in the bedrooms are these spigots that sort of will well, I shouldn't say blow in, but let in the fresh, warm air. There's a lot of ductwork required that is sometimes very hard to fit, and you should be really careful that you seal all the newly made gaps well, in this case with a green tape. And what you end up with is really a very different indoor climate. And just as an illustration, you can see on the top right picture, 3 filters. The rightmost one is a new one out of the box, so that's very white. The middle one is the one that filters the air before it is expelled. So this is what comes out of the house, slightly brownish yellowish. But then the leftmost one is the one that it sits where the air is taken from the outside before it enters the heat exchanger. So this is a Poland grade filter, and you can see it's completely blackened, and this is only after a month of operation, can you imagine? And this is basically what you didn't breathe. Yeah, and that of course, needless to say, makes for a very much improved internal climate. Okay, you saw it already. I'll now break for a little sort of video walk around of the house. Let me try to get that done. There we go. I hope you can see this all right.
Good.
Excellent. So this is the front of the house as it is now. Most of it is the same, but on the side you can see the external wall insulation. It's not neatly finished yet because the front is still an ongoing project. I hope to, well, should I be hosting next year? Hopefully, I hope to be able to show the external wall insulation being continued to the front. They will walk around. Never mind the audio. There's a bit of wind, as you can see from the plants. So yeah, the insulation is quite thick, and it's stopped there to allow the front to continue. Goes all the way up, and there's some I'm waiting for the camera to swing down because the preparation I've done for the front is here. And this is where you can see shoddily covered with bits of old slate is basically, if the EWI, if the wall insulation is the winter coat, these are the winter socks. I've dug down to foundations level, which in our case is, you know, not very deep, and insulated there as well. Because of course your walls, these walls will now sit on the warm side of the insulation. So they will carry heat into the soil and, you know, get rid of it there. And by insulating it below your damp-proof course, if that tells you anything, below ground, you break that path. So now the heat has got to travel a long way to get anywhere, you know, get outside the warm wall. And that, of course, slows down the heat transmission and insulates even further. And of course, your floors are more or less at this level. So it's in our case, where we've got the underfloor heating, you don't want your underfloor heat to heat up the outside. You want it to heat the inside. So these are typically the details you have to be concerned about when doing these things. Again, you can see there is many steps to it. There's the insulation itself. There's a glass fiber mesh. There's a base coat. There's a render. And that, I can tell you, was an awful lot of work to put on this wall that is actually not too big. The house is not very grand, but still is a lot of square meterage. Now, this is a replacement door. The old door was opening the wrong way, we thought, and this is now sitting very much inside the insulation, whereas you can see the reveal for the door is a good deal less deep than the existing window that has been encased in the external wall insulation. It's the thing most overlooked. You buy a high specification door, but then you really have to worry about how to fit it, otherwise it will not reach the design insulation values. And oh, there's over a lot of attention for the waste pipe. Sorry about that. But the wood-clad bit is the extension. Again, very deep window reveals. But there you've got a brick outer leaf on the bottom, and behind that wood is also a small air gap for ventilation and making the wood last longer. And this is then the south-facing bit with the patio doors and the window, all triple glazed. And you can see there's a generous overhang. And this is one of the other things that came out of that calculation the architect did, because this overhang, because it's south-facing, you would otherwise, in the middle of summer, have a lot of solar gain, solar heat that comes into your house because of the sun barreling down through your windows and doors. But with this overhang, they are shaded in the hottest part of the day when the sun is highest. So the influx of energy is limited by that overhang. And there you can see the upstairs, the EWI wrap, the external wall insulation wrap continues in the back of the house, and the solar panels as well. Right, results. Results in numbers first. Just now stuck on this page. Yes, results in numbers. Right, so this is the development of our energy use. When we came to live here in 2011, you can see almost 3,000 kilowatt hours in electricity, over 6,000 kilowatt hours in gas. I mean, of course, there is mild winters and there's harsher winters. The year after, the gas use shot up because of the less mild winter, I guess. The solar photovoltaics and the water heating brought down the electricity use a lot, but you couldn't see it in the gas, probably because the winter was just a bit harsher. And then we proceeded with loft insulation, topping up that old 100 millimeter to the standard of 270, I believe. We introduced the smarter heating controls. And you can see the gas use came down, but it's still hovering at a quite high level. And then you can see when the external wall insulation came on and we did the floor insulation and also the boiler replacement, then it came down by a good factor of 3, thereabouts. It does tell you that small measures are worth doing, and you should do these, but the big measures make the big changes. And that's something you really can't get around. I tend to think that the equivalent we are at now would be an A, but I'm not entirely sure because the official calculation has never been done. And probably my projection is a bit too conservative. I think we might save even more on gas. Now, these are the numbers. And when talking about eco measures, people always ask you, yes, but does it pay for itself? Well, purely out of the gas and electricity bills, I would say hardly. But if you're looking at the results in experiences, that is quite different. Our house is now at a very even temperature throughout. In the summer heat wave, the insulation works the other way, something I had not really anticipated. And, you know, by sensible measures, you know, closing the curtains in the daytime and so on, the house doesn't get over 25 degrees, which is great. Even when it's, you know, even in a record heat wave of 38 outside, it was 25 inside. At the moment, I'm sitting at 20.5 degrees, you know, and we haven't had the heating on yet. So it is very, very warm in winter, cool in summer. And not only does it do that over the year, but also, you know, we used to huddle in the living room, keeping all the doors shut in the winter because of that staircase was so horribly cold. That is no longer the case with the air tightness and the insulation. The house is, all rooms are more or less the same temperature. There might be a few degrees difference upstairs, downstairs, but not much. And the, of course, the MVHR, bless the thing, has got a, takes care of this much healthier climate indoors. You know, there's no more clammy bed sheets. You can dry the laundry indoors because of the increased ventilation. And I think the biggest win actually was that one of the members of the household could stop the antihistamine medication for allergies. That was really a big win. And probably the spores or the pollen that sets it off are now all caught by that filter I showed you earlier in the slides. Other things are that we don't have any condensation on the windows in the winter. That is partly due to the triple glazing, but also the MVHR, which makes the indoor air a bit drier. And you end up with a very silent, serene internal atmosphere. And those are all things, and I could go on a bit singing the praises of this. This is all hardly expressible in cash savings, but they do make the house such a better place to live in. And actually that was my last slide. So I'm not sure, Tom, do you want to take over, or do you
Chris is going to call on
Yeah,
some
sure.
more questions.
Okay.
So thank you very much, Bart. Fascinating, and certainly admire your passion for the project and your commitment to it. It's really inspiring, and I imagine quite a few of us here will agree with that. Since during the second part of your presentation, we've had a few questions come in on the chat board, ranging from the very specific to fairly general questions. I'll ask the people who have put the questions just to voice them themselves, and we'll take them in turn in the order in which they've arrived. So please, could I have Libby Peachy first, just to introduce her question, please.
Hello, that was really interesting. And my question is possibly not one that you can answer, but maybe you have an idea. I've got an air bricks in a couple of the old rooms in my 1930s house, and it's got, I don't have cavity walls. I thought about blocking up the air bricks. Well, I did one year, but is that a good idea? Or should I keep the ventilation going because it might get damp otherwise? I don't know.
Yeah, there is a risk of damp. It depends. I could block them off because I had an alternative in this fancy MVHR. You should keep some level of ventilation. These air bricks were designed in to adhere to the building regulations that were present at the time. Another thing they do is they let fresh air in for any gas-fired appliances you might have. If you have a gas hob, it needs oxygen, and you need to get rid of its products. And the same goes for our old back boiler. There are requirements on how much openings you should have when you have these devices sitting in your house.
Okay.
Same for wood burners and needless to say, open fires and that kind of thing.
Okay, thanks. I've got a well-insulated extension, but I've just got the rest of the house is a nightmare. So anyway, thank you.
I would start with the unintended holes. You know, the things around windows, window sills, for example, and what comes up between floors. And I think Tom could plug his. I'm not sure whether you're going to do a session on it again, but Tom has done a successful session on airtightness and draft sealing and that kind of thing.
Yes, I'm sure we'll do another one next year.
I wouldn't start with the double brick holes. Those should be last.
Yeah, okay, thanks.
Thank you. Moving on to our second question. This is much more to do with the economics of what a renovation project produce. Question is placed by Roba, and I wonder if Roba could give the question now. Thank you.
Okay, I'm actually Sue Roberts, why it comes up as Rover. But,
we won't hold it against you.
Sorry about that.
Okay, I watched another one of these presentations, and it was the house, a Victorian house that has been fully retrofitted and insulated, and they said it cost £200,000 to do. And I'm just interested to know whether you think the value of your house is ever going to reflect the amount that it's cost you to do all the insulation. I take it that you've done quite a lot of it yourself, which probably makes a lot of difference. But I'm interested in having insulation done, but I'm just interested in the economics of it all.
Yes. Yeah, what to say? Okay, the thing I was sort of trying to calculate, although it's hard, is how much the eco aspect added cost to the extension. And I came to a figure of like 15%. And with that in mind, if you have an extension, build it to a proper standard. Mm-hmm. Retrofitting can be a very expensive hobby. And there are two options. Either you go for a system, if that exists for your house, which is, if in a case of Victorians, probably not true. But you know, there are councils in the country that have like retrofitted 100 houses, and then you can come with a prefabricated panelized system, and you do all of them up, and then it's sort of economically viable. Or I'm afraid to say you have to do a lot of DIY.
Right.
There's no easy way around it. I mean, these £200,000 projects for a 2 up, 2 down, they are completely professionally carried out retrofits. Unfortunately, a lot of those sort of showcase products have almost money is no object approach, and that's a bit of a shame.
Yes. Yes, I mean, my house is actually Victorian. It's full of leaks. It's going to, you know, I want to put an extension on the back, which will be properly insulated, but will it not be the case that if I do that, all the heat that the insulation on the back saves will just go out the front anyway? Am I explaining myself properly?
In a way, yes. Sorry to sort of all push all kinds of numbers on you, but I had the same, of course, when doing this, I had the same sort of questions in my head, and a little calculation showed that although the extension is a single story, so it's got its own roof, it's got its own floor, it's got its own walls, the whole extension loses as much heat as the piece of external wall that it covers on the old house. So basically, by bolting on a high spec extension, the energy footprint of the house stays the same, but you get more space in return. And that was actually the starting point. But I have to say that if you have a properly insulated extension you're planning, make sure that how it joins the existing house is done right, because it will be very hard to retrofit insulation on your existing house when the extension then provides all kinds of cold bridging, if that rings a bell with you.
Mm-hmm. Yeah.
You should
Yeah.
think ahead. You should think long term. Otherwise it gets very difficult and very expensive with that, of course.
Yeah, yeah. So I'm going to need good architects and good builders to do things for me. I think you put up on the chat, Tom, that you builders, and did I notice that just now?
Yes,
People that do
Bart's
this
got
work.
a
Yeah,
very
professionals.
detailed
Yeah.
list of who worked on this project, and quite a lot about the details and
Okay.
costs.
Okay.
Yeah, I
Okay.
must say that it's architecturally, at an architect level, I should say, retrofitting is sort of well understood. But to actually hire people that can and will build what the architect specifies, that is the hard bit.
Right. They're not specialist builders who do all this.
Well, there are, but then you end up with a £200,000 project.
Yeah. Yeah. Okay. Thank you. Yes.
Yeah.
Yeah.
Thank you. I'm wondering if Margaret Reynolds, who's with us tonight, has any comment on that about costs of retrofitting and architects and so on.
Yes.
Oh dear.
Margaret, your line is breaking up a bit.
I can just say that there is a website that discusses the value of houses in terms of their EPC, and it is relatively cheap to get an EPC, so it might be interesting if Bart of your house does go up as you improve your EPC. That's the only in a house that I did, people did put more 250,000 into the house and got it back when they sold it. And they even made another 90,000 on top of that. So I think it's fair to say it is worth it in value. The problem is getting the money up front.
Right.
Yeah, to support the EPC claim, less than 0.1% of the houses sold have an A rating.
Yeah.
And even a new build will only put you halfway the B band. So if you can put a house on the market that has an A energy label, that is, going by Margaret's comments, that is worth an extra premium. There are very few houses that have that.
Yes, but EPCs are very quirky. They're not a brilliant measure, and it isn't surprisingly difficult to get an A. And things that get A's are often people who know what you need to get an A and not necessarily what makes a comfortable house. So it's a flawed system, but it is, generally speaking, worth it to get your EPC value up higher.
Thank you, Margaret. Thank you,
Better.
Bart. Could we perhaps move on to another question as time moves on? This is from Johanna Davies. Could Johanna Davies give her question, please?
Hello, it's kind of related to what you've been talking about. My question is, did your architect have particular passive house expertise?
Yes, they did, lots. They work with this PHPP software all the time. And this is something I could recommend because they know what works. I mean, the passive house software doesn't say you should use these windows or you should use that kind of door or you should use this sort of insulation. You can make trade-offs. You can say, oh, I want to have an extra window, but then I'll just make the wall insulation a bit thicker. Oh, I want to use a very cheap material for my roof insulation, but then I make it a bit thicker. So you have to work this software, as far as I understand it, to get the outcome you want. And the nice thing about this architect was that they have so much experience that they can come up with this options report where they run your existing house through the package, see how it performs, and then start tinkering with different measures to reach different standards. And then you sort of end up with a wish list. It does make it, that is an optional extra. But I was glad I took that one out.
Thank you. Margaret Reynolds has a question about the resources put into your work.
Yeah, this is just because one thing that's so unusual about Bart's house and his project is that he did it himself. And I just wondered how many hours a week you estimate you spend on construction work. And I mean, you're clearly somebody who is very interested in this and very good at it, but did you have prior building work experience before you tackled such a thing?
No prior building work experience, just too much confidence, I guess. And I must say, right, so just to downplay my role a little bit, the architect, of course, came up with a wish list of what we should be doing. Yeah. Builders did the raw build. I sort of self-managed the build afterwards. Well, of course, I was very involved with the builders, managed afterwards myself by employing tradespeople directly, and you know, picked up all the eco-specific bits myself. But I must say, a huge amount of time went into it, not only daytime, and I was lucky enough that I could get some unpaid leave from work at the time, so I could, you know, spend at least one day a week on the site while the builders were working, and you know, a bit more before and afterwards. It's not so much the hands-on itself, but also endless reading and studying and making calculations to see what you should be doing. And you know, I made a few mistakes. With hindsight, I should have done things differently. I should have sequenced it differently, you know, attacked things from a different angle. But generally, it's sort of okay. But it is endless reading.
Yeah, I think it's interesting that the way things are moving nationally is that what you did, getting Alan Budden, who, by the way, is a very, very good architect and had many years of experience of this kind of thing, to get an architect to set up the design of the renovation is what the whole country is moving towards. It's a role called a retrofit coordinator, but you don't necessarily have to use that new role. You can have an architect, as like Alan Budden, set up the strategy and how you would carry that out. But most people, I think, would balk at trying to run that work of that technical complication themselves. So, you know, hats off. I think it's very interesting that you've done it. There are not that many builders who want to go that route. It's so difficult.
I was very lucky with the builder. He was, you know, he normally does small standard jobs, but he was happy to learn and take on new things. And he did say at some point, yeah, Bart, I think you're a bit ahead of the curve, but you know, I have to do this because in 5 or 10 years, everybody will want this. Yeah. You know, that's, yeah, I was very happy. I'm very happy with him. He always wanted to do the right thing. And, you know, but it did mean that sometimes you have to design details on the spot. And that was a bit frightening out now and then. It kept me awake for a good few nights, yes.
Is he a one-man band? Or does he have a lot of people working for him?
Basically, he is. Well, he's got a few partners. You know, he's been working with for a very long time. They always show up. He always shows up with three folks. But in generally, he manages it. But you know, little overheads means very cost effective.
Yeah.
Thank you. We've tackled all the questions that have come in on the chat board. So thank you for those very valuable replies, Bart and Margaret, for your contribution. Perhaps I'll hand back to Tom now, just to bring the meeting to a close.
I was just going to tell you about the thermal imaging training. Can you see that? It does sound. Can you see a slide about thermal imaging?
Yes, I can, yes.
Oh, good. And so through the winter season, we'll be running online thermal imaging training sessions at those times. So in an hour and a half, we will talk about how to use our cameras. We have CCF has 2 thermal imaging cameras we can lend out, and they're really good for spotting where your home is losing heat, whether it's drafts or poor insulation or all of those things, and for checking on your heating system too. And so I'm afraid the booking for these trainings is not open yet, but keep your eyes open, and soon you'll be able to book in for one of these training sessions and then borrow a camera. And
Just comment that the website for training is on the chat board now, and so if you save the chat at the end of the meeting, you can put that on record for when you want to book.
thanks. And so there are still some more tours, and in this autumn season from Open Eco Homes that this is part of. On Monday, there's a talk about heat pumps, which could be really useful. Quite a lot of detail in that. If you're interested in considering buying a heat pump, do come to that on Monday. And there's 3 more home tours that are coming up. So, well, thank you so much. It's really useful to see this in detail.
Yeah, yeah, very good.
Okay, thank you Tom for hosting.
Good.
And yeah, hope we'll be back at some point.
Good luck with your own home energy improvements. We'll have an email. I'll send an email tomorrow with links to this and to a video of what we've been recording. All the best.
Thank you.
Good night.
Thank you very much, Bart.
Bye.
Right.
Thank you.